All right, welcome to topic 17, graph, quadratic, and absolute value functions. We talk a lot about transformation, inverse functions, composition of functions before. We also talk about operational functions. We even, talk about all the basic graph of all the functions in the previous topic. All right. I'm not going over linear function in this class because linear function or linear equation is more like Math 108. But in this class, I do want to talk about quadratic and absolute value functions. So we learned about solving quadratic equation before in class like Math 108 or intermediate algebra. We talk about how to solve absolute value equation in those classes too. So I'm using this topic to kind of talk about their graphs. Okay, I showed you the basic graph of quadratic function before and the absolute value function. So today we're just going to talk more about them and we're going to learn how to graph them by hand as well. All right. So let's start out with quadratic function. Absolute value function shares very similar characteristic as quadratic functions. So I want to start out with quadratic first. All right. So this first objective is finding the vertex of quadratic function. Sorry about that. Well, quadratic and absolute value function. Okay, they share very similar characteristic. All right, so the standard form, okay, the standard form for quadratic function is ax squared plus bx plus c. There's another form, general form, called for quadratic function is a times parenthesis x minus h whole thing squared plus k. All right. And the absolute value function has this standard form, a times absolute value of x minus h plus k. So I'm going to graph both of them, okay, in the graphing calculator, and I'm going to talk about what's the vertex, axis symmetry, and so forth. All right. So what is H and K? H and K is called the vertex. Okay, the very bottom of the U and the very bottom of the V, that is called the vertex. Okay, so there's another word for them. It's called the absolute maximum or absolute minimum. So the most basic parabola or quadratic function is simply x squared. So it's simply just a u. Oops, sorry. The very, very bottom of that u, the very, very bottom of that u, that point is actually called the vertex. So by learning about transformation, you know this vertex is actually the most basic one. It should be originally at the origin, 0, 0. All right. Let me graph a absolute value function. So math, go to numbers. Number one, absolute value of x. Look like a v, right? Parabola is a u, absolute value function is a v. So the most basic absolute value function is absolute value of x, just a v, and the vertex is located at the origin, the very bottom. So if I have a parabola that opens downward, then the vertex will be the very top. All right, so is the V. If my V point downward, then the very top will be called the vertex. What is so-called the axis of symmetry? Axis of symmetry is referring to a vertical line that will actually cut through your parabola or your V in exactly half. Okay, so it's mirror image on both sides. Left side and the right side are mirror image to each other. So the axis of symmetry is simply a vertical line that will actually cross through the vertex, cut your parabola or the V in two halves. All right. So since my U and my V, the vertex sitting at the origin, and the axis symmetry is a vertical line that cut through them in exactly two halves, then the equation for my vertical line got, or the equation for my axis symmetry got to be x equal to 0. All right. So whatever the vertex, whatever the x value of the vertex is, that should be the equation for the axis of symmetry. Now from the transformation, we know that these vertex will move to different places, okay, based on the horizontal and vertical shift. Therefore, the axis of symmetry move along with it as well. So the graph of a quadratic function is called a parabola. The very top or very bottom of the parabola or the V, okay, is called the vertex. And we denote them as h comma k. So if you look back on the form, the h and the k is actually your vertex. So when your function is written in the general form, you can actually extract the vertex right away. And remember, and I kind of mentioned this before without saying too much about them, the formula calls for x minus h inside the parenthesis or the absolute value, okay, when you read them in general form. So once you're matching up, the x, the sign and whatever that h is, make sure everything matches up so you know what h and k is. So I remember this on the homework where you have to factor something out for the absolute value, okay, in order for the x minus h to actually matching up. So we kind of mentioned that before. So here we will look at it again. The very top or the very bottom is also called the absolute minimum or the absolute maximum. So we talk about maximum and minimum before, which is referring to the y value. Parabola and the absolute value function is symmetrical. Half the graph is mirror image with the other half. So that's why the axis of symmetry, okay, actually cuts your u over the v in exactly two halves. So they become mirror image of each other. The right side and the left side are exactly the same. So that makes sense in terms of when we talked about the even and odd function, right? U parabola and absolute value function are both even functions. Okay, they are even functions. So remember we talk about parabola opens up is symmetric to the in respect to the y-axis, right? The reason why we say y-axis because the vertex was located at the origin. But if the vertex is moving to, let's say, maybe 2 comma 3, something like that, just the vertex has moved, all right, then your parabola is then symmetric to its axis of symmetry. Okay, so if a vertex moved to 2 comma 3, then the axis of symmetry, that vertical line that cuts the parabola in two halves, the equation for the vertical line got to be x equal to 2. So a better way of saying is your parabola and the v is actually symmetric to its axis of symmetry. All right. So axis of symmetry is simply a vertical line that goes through the vertex, and the equation for it is always x equal to a number. So here is just a couple reminder on the transformation. If the number a, remember number a is actually in front of the entire function. So if I go back up to the form, the number a that's in front of the function, okay, tells me, well, if a is bigger than zero means positive. If it's positive, it opens up. If it's negative, opens down. All right. If that numerical value of the a is between 0 and 1, then the parabola will open y. Okay, open y means vertical compress. Open narrow means vertical stretch. So if A is actually bigger than 1, you actually, the graph will appear to open narrow. All right, so here I'm using a little bit more generic wording, wide and narrow, but they are the same thing as vertical stretch and compress. All right, so I'm gonna matching up the form, okay? Match on the general form. So for the following quadratic function, find the vertex. So my form says f of x, right? This is written in general form, is equal to a times parenthesis x minus h whole thing squared plus k. So right now is negative parenthesis x plus 3 whole thing squared plus k plus 4. So if you're matching up, right, x match with x, but the plus sign does not match with the minus sign. The formula called for minus sign. So why is this plus? Well, technically this plus 3 is supposed to be a negative something, right? Supposed to be a minus sign. That's what the formula calls for. So in order to become a positive 3, you got to be minus a negative 3. So now the subtraction sign match with the subtraction sign, therefore negative 3 match with the h. So your h technically is negative 3. All right, so that means I have shifted to the left 3 places. Plus sign, plus sign. 4 is the k. So your y value of the vertex is actually positive 4. So that's how you can extract the vertex very quick. So I kind of mentioned that before, without using the word vertex. Okay, that's how I can look at a function sometimes, and I know exactly where it's shifted to because the general form, the h and k tells me what they shifted to. All right, the axis of symmetry is a vertical line. It's a vertical line that cut through this parabola. All right. So before I do that one, I'm gonna kind of draw a picture here. Parabola opens up or open down. So my A is actually a negative sign. If it's a negative sign, it opens down. All right. Since this is a negative 1, so it actually does not open wide or narrow. I can say either. It just open normally, as compared to the regular 1x square. So this parabola I know opens down. And the vertex right now is located at negative 3, 4. And open down, as you can recall, is a reflection about the x-axis. Okay, it's the same thing. So the axis of symmetry is a vertical line that cuts through my vertex. So when it says find axis of symmetry, it's referring to the equation for that vertical line. So you have to say x is equal to negative 3. That's the equation for that axis of symmetry. Okay. If you simply say negative 3, that will actually be incorrect. You got to write out the equation for the axis symmetry. All right. So how do I find the vertex if my quadratic function is written in this form, ax squared plus bx plus c, the standard form? Well, this thing called the vertex formula is actually derived from a lot very similar to how you complete the squares. Okay. In Math 108, I don't talk too much about completing the squares. That is actually something that has been moved away from. But if you complete a square on this formula, you can actually derive the vertex formula called the so this parenthesis, right, is a coordinate. Negative b over 2a is your h. So all you have to do is substitute your coefficients from the quadratic formula to find h. The k is f of negative b over 2a. That simply means f of whatever the x value is for the vertex. So makes sense. If I can find the x value of the vertex, then all I have to do is substitute negative 3 back into the function to get the output y value of the vertex. So that's what this formula right here is saying. F of whatever x value is, then the output will be the y value of the vertex. All right, so normally we just denote the vertex as h comma k. So let's give it a try. Okay, let's use the formula. Find the vertex. So in order to find the vertex, you got to write down your coefficient. So my A is 8. My B is 10, right? C is -3. So to find H, or the X value of the vertex, the formula is negative B over 2A. So that will be negative B is 10 over 2 times my A. So that's negative 10 over 16. So you can put in a calculator, it will reduce it for you. All right, so that will be negative, reduced by 2, 5 over 8. This number is extremely hard to find from the graphing calculator because there is a way, if I would just enter this 8x squared plus 10x minus 3, there is a way to find this vertex. All right, there's a way to find this vertex in a graphing calculator, but if the answer you're looking for turns out to be a fraction, like the negative 5 over 8, then the calculator will never display that fraction. Calculator only displays decimals, integers, okay? It does not display fractions. So if your vertex is ever like a fraction, then it's actually better off to do it by hand, okay? Because graphing calculator or the features that inside the second calc normally just give you integer answers or decimal approximations. Okay, so sometimes we still have to do some of this stuff by hand. But I'm going to use a calculator a different way to help me to find k. K is actually f of negative b over 2a. That's what the formula says. And we just found negative b over 2a is negative 5 over 8. So I'm simply going to substitute negative 5 over 8 back into my function. So that will be 8 times negative 5 over 8 squared plus 10 times negative 5 over 8 minus 3. All right, so basically to find the y value, all I gotta do is substitute my x value back into the function to find the y value of the vertex. So I input the x value of the vertex, so the output will be the y value of the vertex. All right, so in the calculator, I'm gonna go back to the home screen. I'm just gonna enter all this in the calculator. I'm going to say 8 times parenthesis, negative 5 over 8, close parenthesis, to the second power, plus 10 times parenthesis, negative 5 over 8, close parenthesis, and then minus 3. So when I press enter, it gives me a decimal approximation. So I'm going to go back to math and choose number 1, convert to fractions. Then press enter. So the y value is negative 49 over 8. So my vertex as a coordinates, we will say negative 5 over 8, comma, negative 49 over 8. That's my vertex. All right, so this parabola we know is open up because the A is actually a positive 8, not a negative. Axis of symmetry is the vertical line that will cut through my parabola in 2 halves. So the vertical line should have equation x equal to negative 5 over 8. Right? Vertical line, x value, right? All right, parabola open up or open down, open up because the A is positive. Open wide, open narrow. Open narrow, you kind of saw it because this 8 is bigger than 1. So it's open narrow. Since A is equal to 8, greater than 1, so open that. Since a is equal to 8, which is greater than 0. Greater than 0 means positive, okay? Every time when you see something greater than 0, it's referring to positive, or to the right of that. All right, so that's just real quick showing you how to use the um, vertex formula to find the vertex if your function is written in the standard form. If your quadratic function is written in general form, we can always extract h and k pretty quickly just by looking at it. All right, next objective. Finding the intercepts of your quadratic and absolute value functions. All right, so your intercepts, okay, we talked about this in Math 108 before. If you took that class, x-intercept is where the graph cross over the x-axis. So what's so special about it? Well, if I would just draw you a linear function, if I draw you a linear function, the point the point where the line cross over the x-axis, that is called the x-intercept. And what's so special about it? And I kind of mentioned this before, okay? Where are y equal to 0 at? Where are all the y value equal to 0 at? Yeah, well, they are actually at the x-axis. So x-intercept means find x value when the y value is 0. All right. So in order to find x-intercept, you simply set the function, which is y equal, set the y equal to 0 so you can solve for x. So every time, what that means is every time we are solving for x, we are basically looking for the x-intercept. Y is the quadratic function. Y is any quadratic function always equal to 0. Well, technically, what it's saying is y is equal to 0. Because if the quadratic function is equal to 0, I'm solving for x, right? This part, y equal to ax squared plus b, this part is graphing part. This part is solving for x part. So if you put the two together, you are basically saying, okay, well, I'm finding x-intercept, my y value is always equal to 0. Okay. Y-intercept is where the function cross over the y-axis. So on the y-axis, all the x values are 0. Your job is to find the y value. Okay. So x-intercept means find x. Y is 0. Y-intercept means find y when x is equal to 0. Now, after in the next topic, begin the next topic 18, we're going to talk about something similar to x-intercept. When it comes to finding the x-intercept, it is a lot like finding what we so-called the zeros of a function. Okay, the zeros of a function. So whenever I say the zero of a function, that means the y value is 0. So that's a lot like finding x-intercept. But the concept of x-intercept and the zeros of a function is naturally not quite the same. Okay, so we will talk about it in the future. Finding x-intercept is a lot like finding the zero of a function. The way how we go about doing it arithmetically is the same. Okay, but the concept of the zero and x-intercept are actually not quite the same. All right, we'll actually get into it starting with the next topic. So with that thing being written up here, all right, quadratic equation is a squared plus b plus c equal to 0. That's the equation part. The graphing part is f of x equal to that. So when I put the two together, right? So what that means is to find x-intercept, we literally set the function equal to 0. Thus, the x-intercept we found can be considered as the zeros of the quadratic function as well. All right. If I am able to find an x-intercept, Okay, if I am able to find an x-intercept, then that x-intercept is also called the zeros of the function. What if I have a parabola that never cross over the x-axis? If it never cross over the x-axis, I actually have no x-intercept. So x-intercept is not quite the same as the zeros, because if a function does not cross over x-axis, you have no x-intercept. But there are zeros of the function. You can actually have a zero of a function, but you actually have no x-intercept. Graphically, graphically, you can actually determine just by looking at the graph, well, if I don't cross over x-axis, I have no x-intercept. But I will always have zeros of a function. All right. So let's take a look at how we can find both intercepts real quick. So to find x-intercept, we set the function equal to 0, right? Because this is y. F of x is the same as y. So I'm gonna say y, replace f of x over the y as a 0. So that'll be 0 equal to ax squared plus 10x minus 3. So I'm basically solving for a quadratic equation. Let's see if we can factor it. For 8, I can use 2 and 4. For 3, use 3 and 1. And I knew to put 3 here because I can get a 12 in the middle. 12 in the middle, 2 on the outer. My outer is 2, my inner is 12. 2 and 12 combined will be 10 in the middle if I subtract. All right, since the last sign is negative, the choice for the two signs are one positive, one negative. So to end up with a positive 10 in the middle, the plus sign gotta be given to the bigger of the two, inner and outer. So the inner need to be positive, outer need to be negative 2. So that'll be 2 times negative 1. The other one is positive. All right, set each factor equal to 0. So we reviewed this before on how to solve quadratic equation by factoring. So move the positive 3 over, divide both sides by 2. X is equal to negative 3 over 2. All right, move the 1 over, divide both sides by 4. X is equal to 1 over 4. You see both x-intercept, you're not going to be able to find them on the graphing calculator under the tables because none of these are actually integers. All right, write the answer as an ordered pair. So my x-intercepts will be negative 3 over 2 comma 0, right? X-intercept is where the function crosses over the x-axis. So that's when y is equal to 0. So we got to enter them as coordinates. Negative 3 over 2 comma 0. The other one, 1 over 4 comma 0. Let's find the y-intercept real quick down here. Y-intercept means find the y value when x is 0. So that means I'm going to substitute 0 for x. So f of 0 now will be 8 times 0 squared plus 10 times 0 minus 3. So 0 plus 0 minus 3 should be just negative 3. Because these terms all cancels out, become 0. So my y-intercept will be at 0 comma negative 3. All right, let's try another one, see if we can factor this, okay? So x-intercept, find x when y equal to 0. So I'm going to set my function f of x equal to 0. I'm going to factor. For 9x squared is 3x and 3x. I think this is a perfect square binomial because the first and last terms are perfectly squared. Not quite, right? 3 and 3 combined will give me 6 if I add. See, the last sign is negative. So this problem cannot be factored. So if I cannot factor, then I can use my quadratic formula. Remember, quadratic formula says x equals negative b plus minus square root of b squared minus 4ac. Whole thing, both term on top, over 2a. So my coefficient A is 9. Coefficient B is -6. Coefficient C is -1. All right, all I'm going to do is substitute my coefficients. So my x should equal to -b, that'll be -6, plus minus square root of my b, -6 whole thing squared, minus 4 times my a, 9, times my c, -1, whole thing over 2 times my a, which is 9. And I show y'all before, the trick to do this is first thing is to enter what's inside the square root into the graphing calculator. Okay, put that in the calculator and see what that is. -6 squared minus 4 times my a times my c, -1, which is positive 72. So -6 is positive 6 plus or minus square root of 72. Whole thing over 18. All right, let's see if we can break down the 72. Got simplify my radical. All right, I'm gonna use prime number 2. 2 going to 72 should be 36 times. All right, 36 is 6 times 6. So I can actually say, all right, the entire 72 is gonna be, since I got 2 6s, these 2 6s will go outside as one of them. So that will be 6 plus 6 times square root of 2 should be left inside the radical, whole thing over 18. When all three number on the outside can be reduced, I will reduce them. Remember, the top has two terms, okay? So when this 6 being reduced into a 1, that you have to write that 1. So your answer for x-intercept is actually 1 plus minus. Your second term is just now square root of 2, both terms over 3. All right, so your two x-intercepts are 1 minus square root of 2, both terms over 3. The other one, 1 plus square root of 2, whole thing over 3. All right, let's find the y-intercept up here. I'm running out of space down here. Y-intercept, find the y value when x is equal to 0. So I'm going to substitute 0 for x. So all these terms cancels out. I just end up with -1. So my y-intercept, 0, comma, -1. All right, let's try another one, okay? Quadratic function, but this time it's written in general form. So the same step, I'm going to set my function f of x equal to 0. Find x when y equal to 0. Remember, this is only two terms. I'm going to show you right here how this problem have no x-intercept. This is only two terms, so I'm not going to multiply this out. All I'm going to do is isolate my x squared term, my variable term, by simply moving the positive 1 over. So x minus 2 whole thing squared is not equal to -1. To get rid of this x squared, I will take a square root on both sides. When I take a square root on both sides, my answer is always positive and negative. So square and square root cancels out. I end up with x minus 2 equals positive, negative. Do y'all remember what square root of -1 is? Square root of -1 is I. Right there, it tells you that it has no x-intercept. Because the imaginary number does not exist on the real number line. Okay, it actually exists on the on what we so called the complex number system. So by having an I tells you that this parabola, this u actually never cross over the x-axis. Just think about where it has shifted to. Your h, x minus h. Your h is 2, your k is 1. So this u is open upward, right? This u is open upward. Now the very bottom has now shifted to 2 comma 1. So visually in your head, if you're having an x-axis, right, 2, 1 is the very bottom. So that means this parabola actually never cross over the x-axis. So you have no x-intercept. All right, so this is how you show it in terms of arithmetic by having that I right there. So if you want to finish the problem, just move the -2 over, put it in the front. So x is equal to 2 plus I or 2 minus I. No x-intercept when you have an I right here. All right, the V. Let's take a look at this V. X-intercept. Find x when y equal to 0. All right, so f of x, replace f of x with 0. So that's absolute value of 2x minus 9 minus 3. So we mentioned this before to find, this x technically can be a positive or negative number. So that's the reason why after we isolate the absolute value, we should set up two different equations. So move the -3 over. So this is now absolute value of 2x minus 9 equal to positive 3. This is called the standard form of the absolute value equation, where the absolute value term is by itself, everybody else on the other side. Then from here, you can set up your two equations. So all you're going to do is set what's inside the absolute value equal to that positive 3. And the other equation is set what's inside the absolute value equal to the -3. And you solve for both x. So this should be 2x equal to 12, right? Move the -9 over. X equal to 6. Move the -9 over. That's 2x equal to 6, I believe. X equal to 3. So 3, 0, and 6, 0 are the two x-intercept. For the y-intercept, I'm going to find y when x is equal to 0. So I'm going to substitute 0 for x, okay? And put it up here. 2 times 0 is 0. 0 minus 9 is absolute value of -9. Absolute value of any number is still positive. So this is really 9 minus 3, which will give me 6. So my y-intercept, 0, comma 6. Okay. All right, I'm going to take a break on this right here. I'm going to take a break from the first part, and then the second part of this video we can talk about we can do more of those problems. I'm going to show you how to graph it here.